Hi, do you want to know what is new in MICROSAR Classic with R33? Well then, just stay tuned. I'm Andreas Wenkebach, Product Manager of MICROSAR Classic, and I want to present R33 highlights I selected for you.
Now let's have a look. There is a rework of our complete memory stack. What I announced in my last video has now started to effectuate. Our ISO 1511820 complete charging solution gets further extended. For heavy-duty vehicle, we can now switch Ethernet controller at runtime. Metadata handling, according to the latest AUTOSAR, improves performance, code size, and flexibility of our communication stack. I want to give you some update on what we added in veSW parameter handling. We considerably improved our support for third-party MCAL drivers. To make it as easy as possible to have your system protected, we added the new veSysProt module, both available for MICROSAR Classic and hypervisor products. Use our mirroring solution to achieve full flexibility. With CDD as destination, many more use cases are available to you now. Last but not least, this isn't about anything that happened in R33, but an announcement of our gateway solution, veGW. The picture you see here illustrates the complete memory stack as specified in AUTOSAR 2211. I already announced NVM Gen 2 and MEMAC in the R32 Spotlight session. R32 laid the foundation, now R33 added significant functionality. Today, I want to give you the big picture of the memory stack renewal activities we have done for you recently. In NVM Gen 2, we have introduced queuing, support for all block and data types previously available, CRC check, and implicit default data recovery. The new AUTOSAR 2311 compliant MEMAC is already being used with third-party MCAL. It is supporting multiple users and multiple memory drivers. Both NVM Gen 2 and MEMAC have achieved ASIL-D quality since R33. Feature completeness for MEMAC is achieved with R34 for MICROSAR Classic, while NVM Gen 2 will reach this milestone in R35. Both new components have been created in a backward compatible way so that you will have a smooth migration in your project. If you use several vector products like MICROSAR HSM together with MICROSAR Classic, you will have to make sure you use in both the same components, so either our legacy VE MEMAC-M or the new AUTOSAR-based MEMAC solution from us. Our documentation provides details on that. With R35, we will completely replace the previous VE MEMAC-M solution with MEMAC for new projects you start. So you should strongly consider to update existing projects like MICROSAR HSM if you receive a R35 based delivery. This is because VE MEMAC-M will be in maintenance and no further development will happen anymore. For NVM, we will keep the legacy NVM solution in releases up to R34 and also replace it finally with NVM Gen 2 in R35. Here you do not have any compatibility issue with other vector products to take care of. Currently, we deliver both NVM solutions in parallel, so you need to decide which one to use for your projects. If you require multi-core support or do need any of the new features, the NVM Gen 2 will be the natural choice. On the other hand, if multi-core support is not needed and you do not have plan to update to R35, the legacy NVM is still a good option for you. If your delivery uses third-party memory, it is mandatory to use the new AUTOSAR-compliant MEMAC. Starting with R34, your default selection should be exactly this. Now let's talk about FlexNOR Ve, which is already well established. The classic Ve has been discontinued since R33, now also for package-based delivery. FlexNOR Ve is based on a modern architecture incorporating lessons learned from the classic Ve experience. This results in a more robust and efficient solution capable of supporting larger flash sizes and offering significant usability advantages. In the picture, we see the old world on the left, where the modules defined by AUTOSAR pre-2011 are shown. AUTOSAR only defined modules for data flash access, but not for program flash. Our vector solution in this pre-2211 world closed this gap with the blocks and modules shown in the middle picture. Due to the lack of AUTOSAR interface definitions, we required some wrapper modules in the past, making the architecture somewhat complicated and divided between data flash and program flash. The clean AUTOSAR 2211 MEM design, driven and brought into the standard by Vector, incorporates the idea of a memory access manager into AUTOSAR. In this new architecture, we see a unified memory layer where data flash, program flash, and external flash are all handled in the same way. This unified approach supports third-party solutions for data and program flash. We encourage hardware suppliers to create these drivers, while Vector would concentrate on the upper layers and external memory. We will still provide legacy platform solutions based on vMem along with MEMAC, ensuring downward compatibility. We expect completely R2211 based MEM drivers for new developments from third-party suppliers. In the end, quite some mixture of components from different suppliers is now possible. This is possible now as AUTOSAR defines all the interfaces, which eases exchanging modules from different suppliers. Lastly, there has been significant work on tooling, which is and will be more in focus in the future. The VE Memalizer analysis tool available via our Vector portal allows you to analyze memory dumps and optimize configurations in the DaVinci Configurator tool. vMem Optimizer, a more recent tool, most notably supports dynamic endurance proof creation for automotive ECUs, replacing the static endurance proof documents provided with our legacy FEE solution. So this is another highlight feature I've selected. We achieved full ISO support in R32, and we aim to stay ahead in this topic within the industry. In R33, we added a feature pretty relevant for heavy-duty vehicles. In heavy-duty, J1939 is commonly used, and different to passenger cars, there's an upcoming requirement to be flexible with the Ethernet controller you use for charging communication. The main driver here is the new megawatt charging system using 10-base T1S Ethernet communication, which is getting available for electric trucks. Due to regional availability differences, an electric vehicle communication controller must support various charging systems and their communication technologies. Now you may wonder if this is always part of the MICROSAR Classic stack. Short answer is yes. Smart charging is part of the standard MICROSAR Classic product. It is an option you can select, so you only pay for it if you demand it from us. The charging solution remains a major focus of our MICROSAR Classic product. It is a shining example where we clearly lead with the best solution in the industry. Another highlight feature is metadata handling, which with R33 release now aligns with the latest standards. It is not only named meta, it is in its essence a meta feature that doesn't directly provide functionality. However, it is crucial for addressing future challenges in the communication stack and some benefits are already in. Let me explain some further why this is a clear highlight to me. So let's at first start with a simple question. What is metadata according to AUTOSAR? Through metadata we can transport additional data, such as CAN ID or socket connection ID, by adding it to PDUs. In the past this actually already was possible, but in rather unclean way. The additional data was only attached straight to the PDU data. PDU and metadata had to be separated in order to allow to consume it. This meant that you had to extract the metadata from behind the PDU, explicitly copying it. Now, metadata is stored behind a dedicated pointer, ensuring a clean separation from the PDU data. This leads to better usability in modeling and configuration, and it avoids the need to copy data. You can reference the same data from layer to layer without copying it, resulting in more efficient PDU transport throughout the stack. Naturally, benefits can only show up if there is metadata information at all. Use cases where metadata is important include J1939 and SumIP, both of which already take profit now from metadata handling in R33. In R34, we plan to support metadata access via the RTE. BSW diagnostic parameter calibration was already in focus in the R32 Spotlight session. Maybe you want to check the R32 Spotlight video again, where I gave a more comprehensive story. Today, I want to shortly recap and explain what we did in R33 for you. So shortly for recap. This feature is crucial in the OEM development process. OEMs want to calibrate diagnostic parameters directly in the car. Obviously, in the car, it would be a hassle to use developers' configuration tooling to configure parameters. The feedback loops to make changes in the configurator to finally load these, the car lacks the required flexibility. So this for short recap. The feature is crucial in the OEM development process. OEMs want to calibrate diagnostic parameters directly in the car. Obviously, in the car, it would be a hassle to use developers' configuration tooling to configure parameters. The feedback loops to make changes in the configurator and then to finally load these to the car lacks the required flexibility. With BSW diagnostic parameter calibration, you can now instead connect directly to the ECU. You now address parameters using a calibration tool right in the live system. We started in R32 with a narrow set of parameters, mainly counter-based debouncing. Now with R33, as you can see here, we have considerably broadened the range of parameters that can be calibrated within DEM. This feature is also relevant for FIM module, where we have added the inhibition configuration parameter set. We are aiming for further enhancements until R35, where a major milestone through a comprehensive basis of parameters will be achieved. So this journey will continue still for some time, certainly. Another highlight is our third-party MCAL driver support, which we will constantly continue to improve. Like with memory, where third-party support is considerably eased, we aim to allow more third-party drivers to get involved. You can now have a multi-controller based setup with both vector and third-party drivers. For Ethernet, this will be only available with R34. As of today, we provide compatibility up to AUTOSAR 4.4 for third-party CAN and LIN drivers. We are continuously adding further compatibilities, so please get in touch and ask for an offer to ensure your required compatibility is provided in time. For Ethernet controllers, we also offer compatibility up to AUTOSAR 4.4. This is achieved via an additional Ethernet driver wrapper. We are continuously adding further compatibilities, so again, please reach out to ensure your required compatibility is covered. A special challenge of Ethernet compatibility arises when using both third-party and vector drivers. This is because, besides lower layer compatibility, you now need intercompatibility between the transceiver driver, the Ethernet driver, and, if applicable, the switch driver on lower layer. If these layers are provided by different suppliers, we must carefully check how or if intercompatibility can be achieved. Certainly, without compromise, we aim to offer the best possible solution for allowing intercompatibility. I also want to make you aware of some important consequences in combining supplier solution relevant for all CAN, LIN, and Ethernet. If you have an AUTOSAR driver that supports functionality which may not be supported by our stack yet, you won't be able to use it via our upper layer modules. Naturally, the compatibility is restricted to what we currently support in AUTOSAR. The good news in all this complexity is we maintain a major proven database to track all our availabilities so that we are able to identify which extensions are necessary for your desired solution at the moment of your request. Certainly, for many platforms and peripherals, we will already have everything you need off the shelf, so let us check for you if you are even that lucky. So this is about the newly introduced veSysProt in R33, the System Protection Module. The module aims to provide you assistance in your desired system protection design and manages peripheral access on your hardware. It allows you to configure domains and certain initiators that need to access system resources. The major benefit for you is the ability to configure and design your system protection use case in the familiar DaVinci configuration tooling environment instead of hard coding it. Achieving a good configuration is still challenging, but through our provided solution, platform-specific complexities are abstracted away and thus hidden from you. Once you configure your use case correctly, you simply generate and have qualified ASLD code that provides the protection logic you defined. Let's take a closer look at what the picture describes. Basic situation is you have a certain resources in your system that you want to protect against access from certain initiators. You see here CAN, MEM, Ethernet as examples. In the first step, you need to define the relevant initiators for which you want to manage access. You group them into domains with shared peripheral access rights. This configuration generates the gateway that will manage the resource access. The veSysProt module is both part of the MICROSAR Classic product and part of the overarching MICROSAR virtualization solution, which is additionally applicable to the MICROSAR hypervisor product. For our hypervisor product, it is key for allowing virtualization to happen by isolating VMs from each other. Let us have a look back to the central picture where you see that the VM can be just another initiator. Consequently, VMs can also be grouped into domains and define their own single domain with certain access rights. The last highlight feature I have chosen is an extension to our mirroring option in the context of our existing option within MICROSAR Classic. So what is mirroring? The underlying principle is rather simple. communication can be mirrored from one channel like CAN to another channel like LIN. Now with R33 we have extended flexibility greatly to a much more generic solution by defining mirroring to CDD. Now you can define mirror target channels with all flexibility you need. For example, you can forward communication to a channel configured to proprietary physical bus. Beyond mirroring to a given physical channel, you can mirror towards a virtual channel, such as a software component. But why would you do that? There definitely are real-world use cases. Maybe you want to perform some analysis in a software component written by you, or simply collect data within it, or extract communicated data to outside the vehicle. Now, last but not least, this isn't about anything that happened in R33, but an announcement of our gateway solution, veGW. Sure, as of today we have solutions to configure and implement gateways. The simplest way to define routings via PDOR module, but this approach quickly hits performance restrictions through the number of routings you can do being limited. To overcome this, it's as of today possible to use veSW split multi-instance feature, allowing routing to be offloaded from the main core to gateway cores, thereby increasing the possible routings you can handle. However, the complexity of required routings in many systems will lead to bottlenecks, still considerably restricting the desired amount of routings. So we decided to extend the stack with a more sophisticated solution for complex gateway projects through both veSW and workflow adaptations. This means we try to avoid cross-core communication by design, aiming to considerably increase the maximum number of routings possible, while optimizing for low latency and high throughput. The picture shows how this idea could look and differentiates two intended setups. In the upper half, there's a setup with a dedicated core for running veGW routings. Most routing activity happens in the dedicated core, reducing inter-core communication considerably. You have a single binary where the whole application for all cores is defined, within addressing different cores. In the lower half of the picture, there is a more specialized use case, here with a dedicated binary created from veGW sources used on a dedicated ECU routing core only. This shall apply for modern innovative platforms that provide a dedicated routing core. The first prototype for this is now available, and until end of 2025, first beta deliveries can be provided to you. I want to thank you for your attention. See you again in the R34 Spotlight session.